Hello everyone, welcome back. So this is a question based on truss, which is a problem related to engineering mechanics, and this was asked in GATE AME 2008, and it was of 2 marks. So first we will go through the question. So here is a truss that is given in the question. We have three members, 1, 2, and 3. We have a force applied on this point P, external force, and we have two supports here. One is a pin joint at point Q, and we have a roller joint at point R. So what is the difference between point Q and point R, that we will see in later part of the video. First we will analyze the question. So what we need to find out is that what is the tension in member QR. So this is the member QR in which we need to find the tension. So what we can find out first is the forces in member PQ and PR. Then only we can find the tension in member QR, because they are interrelated to each other. So coming back to the previous question, that what is the difference between this pin joint and the roller joint. So at point Q we have pin joint, and point R we have roller joint. So for a pin joint, suppose this is a pin joint, so the reaction force that we will get at this point will be in two directions. So suppose this is a reaction, so we will get the reaction in both the direction, in x and y both, and the vector summation of this will give the resultant of the reaction force. And this is for point, this is what is applied at point Q. Now this one is the pin joint, and now we will look into roller joint. So this is a roller joint. So as you can see from the figure that it can move freely in this direction. So so we can say that it will not give any resistance in this x direction. So in this case there will be only reaction in vertical direction. So here it will be only r of y, and r of x will be always equals to 0. So this is the difference. Rx will be always equals to 0 for this roller joint, and there will be Rx which will be not equals to 0 for this pin joint. So now we will look into our question. So first we will redraw our truss which is given in the question. So this is point P, this is point Q, and this is point R. So this is F, which is the external force that is applied on the truss. This is angle 45 degree, this angle is 30 degree. So we will get two reactions here, R of Ry at point Q, and this is R of X at point Q. This will be here we will get only one reaction, R of Y at point R. So as you can see, when we will apply summation of forces in x direction equals to 0, and summation of forces in y direction, these two are equilibrium equation in x and y direction. So if we will apply this one, summation of f of x equals to 0, then we can see here is that r of x at Q is equals to 0, because no other forces in no other external forces that is being applied in the x direction. That's why this one is 0. So ultimately this will also become 0. So now we will go to we will move to point P here. So this is point P, and here three forces are applied. One is the external force, this one is F, and the other forces are this is f of pq, and this is f of pr. Now these are the internal forces that is being applied on these members. So suppose this is member pq, so we assume that there is a tensile force that is being applied in this member. So this is f of pq. You can assume it to be compressive force also. The only difference will be the sign of the solution which you will be getting. Otherwise you can assume whatever you want. We will assume same tensile force that will be acting in f of pr. This point is this point is p, this point is q, this point is p, and this point is r. So moving ahead, as you can see here, three forces are acting at a point, so we can apply one theorem. I will explain the theorem to in this video. So suppose this is a point here and three forces are applied, f of a, f of b, and f of c, and suppose the angle between these two are alpha, these two are beta, and these two are gamma. So we can write here f of a by sine alpha equals to f of b by sine beta and f of c by sine gamma. You can remember this formula like this, that this is the force Fa, and the angle which we will choose is alpha. That means it is the angle opposite to this one. So accordingly this is Fb, and the angle opposite to this one is beta, and this is Fc, and angle opposite to this force is gamma. So we will apply same thing in our problem. So as you can see, this is angle 45 degree. We will drop a vertical line here. So from in this triangle PQ, and suppose we will give a name here PQA. This is 45 degree, this is 90 degree, so this will be 45 degree. And PAR in triangle PAR in this triangle, this is 30 degree, this is 90 degree, so this is again 60 degree. So here you can see that this is I will redraw this figure again. This is F, this is F of PQ, and this is F of PR. This angle here is 45 degree. This angle here is 60 degree. So this angle will be 180 minus 45. So this will be 135 degree. And again this angle will be 180 minus 60 degree, so this will be 120 degree. So we will apply this theorem here. So this is f of sine of 105, the summation of these two, plus f of pq by sine of 120, and f of pr is equals to sine of 135 degree. So we will first take these two. So f of qr will be equals to f of sine of 120 divided by sine of 105. So after calculating this one, we can say that this is 0.896 of f. So then again we will move to point Q, this point. At point Q, so this is f of PQ. Sorry, this is PQ, and here R of y at Q, and here we will get f of QR, and this angle here is given as 45 degree, as you can see from here, 45 degree. So we will write equilibrium equation here at point Q. So summation of fx is equals to 0. That means f of p of cos 45 is equals to f of QR. That is f of QR is equals to 0.896 f divided by root 2. That is equals to 896 by 1.414 into f. So what we will get here is that 0.63 f, and which is this one is our answer. So our answer will be B. Thank you.